Hello all, we are conducting the presentation on our final project, which is Rainfall Measurement System. I am Arya Sir Alex and my teammates are Arjun TS, Sachin Joshi and Tejas Krishna, and we are guided by Assistant Professor Sunada S. Pillai. These are the contents that we'll be presenting. We include introduction, the mission statement, application, target specification, block diagram, tipping bucket mechanism, target users. Use case diagram, process flow diagram, components required, tools and platforms, need metrics, the circuit diagram, the PCB layout, the results, bill of materials, and the activities to be done. And this is the introduction slide. In a world facing unpredictable weather patterns, the ability to accurately measure and manage rainwater has become more critical than ever. So, rainfall measurement system aims to measure the rain in millimeter range with accuracy. By harnessing the power of rainwater data, we are taking a significant step towards mitigating the devastation caused by these intense localized downpours. Moving on to the objectives, we are trying to design a reliable and accurate rainfall measurement system capable of capturing precipitation data in real time, develop a user-friendly interface for accessing and visualizing collected rainwater data, implement sensors and data collection mechanism that can accurately measure rainfall intensity, duration, and volume. Integrate the rainfall measurement system with existing weather monitoring networks or platforms for broader data sharing and analysis. Next is our mission statement. Our mission is to develop and implement an innovative rainfall measurement system that leverages advanced technology in data analytics to accurately measure and analyze rainwater patterns. Our goal is to provide timely and reliable data to enable early warning and prediction of cloudburst events, thereby contributing to the safety and well-being of communities. These are our applications. It aids in effective water resource management by providing accurate data for agriculture, hydroelectric power generation, and urban planning. It contributes to early warning system for potential floods, helping communities prepare and mitigate risks. This project fosters environmental awareness and sustainable development by promoting efficient water usage and conservation practices. Next is our target users that we are considering. So first will be the local authorities and emergency services, meteorological and environmental agencies, non-governmental organizations, government agencies at various levels, and media and communication outlets. The target specifications that we will be considering would be accuracy and precision, measurement range, data integration, maintenance requirements, followed by power consumption and the cost. Next is the block diagram of our project. So our main, the central of our block diagram is the Atmega 328P, which would be our microcontroller. A Hall effect sensor module is connected to the Atmega. To the Hall effect sensor is the mechanical side that is connected, that would be the tipping bucket mechanism. The power supply is connected to all the necessary power needing circuits. The Atmega is connected to a 16 by 2 LCD display to display the data that is collected from the Hall effect sensor. From the Atmega, it is connected to a Wi-Fi module, which is the ESP01, which transmits the data serially to the database. As said earlier, the control unit used in the block diagram is Atmega 328P. The tipping bucket mechanism is the mechanical side that contributes to the measurement of rainfall. When raining, the data which is collected from the tipping bucket in the form of analog signal by the Hall effect sensor is fed into an Atmega 328P. The data from the Atmega is displayed on LCD display. The rainfall data is transmitted serially to ESP01. From ESP01, the data is transmitted via Wi-Fi to database.
Now moving to the tipping bucket mechanism. The tipping bucket consists of a vertical bucket which can hold a specific amount of water. When the amount exceeds the bucket tips to one side, suppose right, due to the movement of the left bucket moves upward, reaching below the funnel at the same time. The water in the right bucket flows out. This process continues when the rainwater is coming through the funnel. During each dip, an electric signal is transmitted by half a sensor when it interacts with a magnet placed on the top of the bucket. The signals are recorded and analyzed by the control unit. Moving to the use case diagram, firstly when the tippy bucket will move at the begin when it starts to rain. Then the hard effect sensor come in contact with the magnet and the Atmaga 328 and the electrical signal generated by the hard effect sensor is run by the Atmaga 328 and it will display it on the LCD display and sends the rainfall data to ESP01 and the ESP01 will send the data to the database via Wi-Fi and the moving to the sequence diagram, the tipping bucket, when the tipping bucket begins to move, the magnetic field will come in contact with the Hall effect sensor, and the Hall effect sensor will produce an electric signal which is sent to the Atmaga 328B. It will send the data to LCD display for displaying, and the rainfall data is sent to the ESP01 CDD, and from there the data will move to the database through Wi-Fi. And the moving to the process flow diagram. First, if raining, the tipping bucket begins to move, or if it's not raining, the system will be in idle state. And the tipping bucket begins to move, the magnet will interact with the hard effect sensor, and the hard effect sensor produces analog signal and send to the Atmaga 328. The Atmaga sends the data to LCD display and ESP01. The ESP01 sends the data through Wi-Fi to database, and the database stores and displays the data.
So next we are moving to the component specification. First one is the Atmaga 328B. So it is a 32 KB of flash memory ensures non-voltage storage of user programs, maintaining content integrity even when power is off. The next one is the Atmaga 328B offers an array of peripherals, including timers or counters, UART, SPI, 12C communication interfaces. The next one is the Hall effect sensor. A Hall effect sensor is a sensor which detects the presence and magnitude of a magnetic field using the Hall effect. The output voltage of a Hall effect sensor is directly proportional to the strength of the field. Its performing voltage is 3.5 volt to 5 volt. Next one we are going to is the 16 by 2 LCD display. An LCD is an electronic display module that uses liquid crystal to produce a visible image. The 16 by 2 LCD display is a very basic module commonly used in circuits. 16 by 2 translates on a display 16 characters per line in 2 such lines. Next one is the ESP01. The ESP01 is a popular and compact Wi-Fi module developed by Espring Systems designed for Internet of Things, that is the IoT and wireless communication applications. Next, we are moving to the acrylic sheet. It is a transparent thermoplastic often used as lightweight and shatter resistant alternative to glass. It has a various applications including in signage, displays, windows and protective barriers due to its clarity, durability and versatility. This is used as our casing, acrylic sheet. So moving to the next slide, it is the tools and platforms used. First one is the Arduino IDE, SolidWorks, Blink IoT platform, Firebase, Visual Studio Code, Easy EDA, Tech Studio, and the MS PowerPoint. These are the need metrics of our project based on the surveys we have taken online and offline. Specifications based on the need metrics we created. The following slide is target specification which we have created based on the data we have obtained from the need metrics. Okay, the following slide is our circuit diagram which we created on this PDA. And this is our PCB layout. Okay. The following slide is our result. First one is the breadboard level output we obtained and the output on the serial monitor. The second is the PCB, the working of PCB. This is the bill of materials based on the components we have used on the project. This is our work plan.
This is our achievements we have gained through our project. The first is actively participated in the Smart India Hackathon and present the idea in front of the evaluation committee and we are selected to the next level. And the second one is the submission of contributory paper in international journal and all research education and scientific methods. And the third one is our paper was submitted and we presented our conference paper, the international conference SPICE 2K24 on MBIT scholars.
At last, we are moving to the conclusion slide. So, the rainwater monitoring system effectively tracks rainfall levels, enabling informed decision making for water management. Its user-friendly interface and automated alerts enhancing overall effectiveness. By collecting real-time data on precipitation, it facilitates efficient resource allocation and reduces water wastage. Continuous monitoring and analysis, the system promotes sustainability by optimizing water usage and mitigating the impact of drought or excess rainfall. These are the references that we used.